anytime you have something quadratic, we did this back in grade 11, you could change it to look like this, was like vertex form, where you wanted to take the x squared and the bx part and get a hint to write it as something squared. Why is that helpful? Well, often, if you have it in this form with the purple box around it, it's something squared plus something, or if there's negatives, it might be something squared minus something, or 1 minus something squared, which matches up with our tan inverse and our sine inverse formulas. And then we could do a u substitution and see what that looks like. So we'll do an example together, okay? Initially, this should not look like a tan inverse u substitution at all. But if I wanted to complete the square with the bottom, remember the x squared plus 6x is your hint. Okay? If this is your hint, dot, 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 I hope you can see that with something squared, there'd have to be an x. That's the only way to get an x squared. Okay? How does the 6x help us tell this has to be a 3? Well, if you actually squared it, your outside would be a 3x, your inside would be a 3x. This number, by symmetry, always is going to be half of this number. And so this is what you'd have to have. That would give us x squared plus 6x. You see that it would also give us a plus 9. So one of the things that we did in completing the square, I sometimes even put like a space here and a space here. Now, depending on what type of completing the square that you're using, if I add a 9 to make that work, if I'm doing that in the same equation, I have to compensate and undo that simultaneously. So if I add 9, I'm going to have to subtract 9. So I'm doing something, but just rearranging numbers. What works out beautifully in this example is 10 minus 9 is 1. So I can rewrite this as x plus 3 squared plus 1. That matches up so nicely with my tan inverse. Okay? You can either, sometimes people feel comfortable going to the tan inverse right away. Sometimes, and I like this, just do a simple substitution. If you just make the u the x plus 3, du is just going to be dx. And then I have it perfectly looking like my tan, so I can write tan inverse of u plus c and then substitute back. Some people feel comfortable going from there to there. And depending on what it is that's being squared, sometimes that's easier. So by completing the square, we nicely got a plus 1. Do we always nicely get a plus 1? No. So let's see what happens. See if my next one, oh, this one probably works out pretty nice too. Ooh, I have a big square root sign. And the x squared is already negative. It's probably going to complete the square nicely to be a 1 minus x squared idea and have sine inverse. So how do I complete the square for this? Well, if I factor out the negative, you see that that would make my x squared positive and my 8x negative. I need something in there. The 8x is the hint. It has to be x minus 4, x minus 4. Right? So, like, technically, if I'm doing, if I'm actually doing it, I erased it. I have to actually do it. I'm actually showing my work while doing this. There we go. There's my root. I factor out that negative, x squared minus 8x. I leave a space. I have my minus 15 still here. The negative does not get factored out of that, and I have another space on the other side to compensate. Before When you're copying things down, it looks like the teacher plugs in that number. I actually don't do that next. The next thing I do is I say, oh, I know it's going to be x minus 4 squared because of that 8. And because I know it's x minus 4 squared, if I multiply that out of my head, then I know this is a plus 16. I write that after I write the x minus 4. And then I'm like, well, if I add 16, I have to compensate. Why is it not intuitive that compensating is adding 16? Didn't I just do the same thing twice? That's not allowed. Why is compensating in this situation adding 16 again?
Because you factored out the negative.
Because that negative would hit this 16. I look like I added 16, but in reality, with the negative out in front, I subtracted 16. So to compensate, I'd have to add 16. Okay? Which makes this a plus 1. You make that tiny mental math error, I tell you this question becomes multiple times more difficult. Because now, when I rewrite it, I could rewrite it with the negative first, or I could rearrange it so it's 1 minus, and now it's a perfect sine inverse 1. And again, you can make u v inside, du is perfectly dx. But again, if you can see this to this, that would be okay. Yes. If you don't write the plus c on an indefinite, no, they'll probably be fine. It's like everybody sort of accepts that if you have plus c, you know that c is any number. Most university professors realize they have lots of opportunities to take off marks off calculus students. They don't really need more. All right, let's have some fun. We complete the square here, and this is the first time that we don't get the nice plus 1. Ugh. Plus we have a 32 on the top, which is just a constant, so it's just there to stress you out. So I complete the square and I have this. Problematic, because what do I have to have? What do I have to have in here for tan inverse of x? I need 1 over 1 plus x squared. The 1 is important. So then we have fun and we just like, what could I possibly do to make that 16 a 1? Well, you could subtract 15, but that doesn't really, if I subtract 15, I have to add 15. Whatever we do, we have to compensate, right? Well, why don't I just multiply the whole bottom by 1/16? Then I'd have to multiply the whole top by 1/16, because then I'd be multiplying by 1, and that would be allowed. Yes, I get the plus 1. I'm not necessarily super happy with the rest of the way things look, but I'll try to deal with that next. Top turned to a 2, it's a little smaller. Okay. What do we need? We need 1 plus something squared. So then instead of writing x minus 2 squared over 16, could I put this all in one set of brackets and have just one thing squared? What would happen to that 16? It's going to be a 4 inside. Yes, I could have written it smaller. I know you're wondering, why didn't he write it smaller? That would have been nicer of him. This quite largely written item says x minus 2 all over 4, and then it's in brackets squared. Yeah, I know I should have written smaller. I'm sorry. And I can pull the 2 out in front, so what am I going to let u equal? x minus 2 over 4. What's du? dx? 1/4 dx. So if I want to replace the dx with something, I'd have to replace the dx with 4d. This one's more complicated, and yet I decided not to simplify in this case. I just did it as, this is a line. If a line would normally have in its derivative a chain rule where you multiply by 1/4, if you have a line and you integrate, you have to divide by 1/4. I really think this is one where I would probably suggest use this. Make your life easier. Use a substitution. I'll do it right underneath, just to show you. Zoom. This also makes things a little bit bigger. Not a bad idea. So, if I did the substitution, I would have the 2 would still be out in front. 1 over u squared plus 1 multiplied by 4 du. That 4 then could also come out in front and become 8. This is just going to be tan inverse of u plus c. And now when I substitute that, I get to that. I think that is a lot nicer. Less chance of getting, like, any kind of substitution probably means you have less chance of making a mental math mistake. So that's not bad to do. All right. We have time? Yeah, we have time for one more. Here we go. What are the really big hints you should use completing the square? They have a square root on the bottom and the x squared is negative. It's really telling you, let's get it to look like this. That's our goal. Then we can use sine inverse. So we start, factor out that negative. Technically, this should be in blue as well. So I wouldn't have written these numbers first. I just would have had spaces. I would have written the x minus 1 squared and then realized I need to add 1 and add 1 because this one gets hit by the negative. Substitute that in. Sometimes you can do substitution in your head to realize you don't have to do substitution. Can you see that if you made your u x minus 1, du dx is just 1. This is, and then you just get that and substitute back would be really easy. So I think this is one that going to it directly makes total sense. So, how many are left? 1, 2, 2 before long division. Get those last 2 done by Monday. I'll put up the answers on Monday. And then we can quickly get to long division and maybe start our second vertical surfaces, which means we can get integration number 4 done by Wednesday. Okay?